Hello. Today we're going to continue talking about sequences. There's another type of sequence we're going to look at today. This one is called a geometric sequence, as opposed to the other kind that we've been doing which were arithmetic sequences. Well, geometric sequences are a little bit different. In a geometric sequence, the ratio, and remember, ratio means a fraction, so we're going to be dividing two things. The ratio of any term to the previous term is constant. That means it's always the same when you see the word constant. And the constant ratio is called the common ratio, and we use the letter R. So what is R? R is when you divide the second term by the first term, or the third term by the second term, or the fourth term by the third term, or the fifth term by the fourth term. When you divide two terms, one following and then by the other previous, you always get the same number, and that's going to be called R. So there's another formula here that we're going to have to memorize, and that's going to tell us what the nth term of the geometric sequence is. What you have to know is you have to know the first term, and you have to know R. So when you know the first term and you know R, whatever term you want to find in this geometric sequence can be found by multiplying the first term times R to the power of whatever the number of term it is you're looking for. You subtract 1 from that. So for example, if I want to find the 7th term of a geometric series, I would say, well, the 7th term is the first term multiplied by R to the power of 6. Or if I want to find the 10th term, it is the first term times R to the 9th. So whatever this term is, you subtract 1 from it, you raise R to that power and multiply it by the first term. It's not too bad, but it's just another formula you're going to have to memorize. So here's another way of saying this. The second term is the first term times R to the first. Or you can also find the third term by multiplying the second term times R, or the fourth term if you multiply the third term times R. So what you're seeing is the previous term multiplied by R will give you the term you're looking for. What we're going to do now is we're going to write some terms of these geometric sequences. The first example, I'm telling you that the ratio, the common ratio is 3, the first term is 2. So if we want to write the first 5 terms, we'll write them out like this. The first term, the second term, the third term, the fourth term, and the fifth term. Well, the first term they give us is 2. Now, if the ratio is 3, the second term is the first term times 3, which is 6. The third term, you can do it 2 different ways. You can use that formula up there, or you can say it's the second term times 3, which is 18. The fourth term is the third term times 3. 18 times 3, I think, is 54. And then the fifth term is that 54 times 3. You see how you're just multiplying it by the R value here? Each time, each one of these gets multiplied by 3, by 3, by 3. And 54 times 3 is 162. So that's one way of doing that. The second term, this ratio is a half, and the first term is negative. So the first 5 terms the first term is negative 20. The second term is negative 20 times the ratio, which is a half, and a half of negative 20 is negative 10. And the next term is negative 10 times a half. Negative 10 times a half is negative 5. The next term is negative 5 times a half, which is negative 5 halves. And the next term is negative 5 halves times a half, which is negative 5 fourths. Because when you multiply fractions, multiply the tops, multiply the bottoms. So that's how you get first 5 terms of a geometric sequence. Now in the next section, what we're going to figure out is whether the sequence is arithmetic or a geometric or neither. If it's arithmetic, we have to find the common difference, and remember the common difference is called D. If it's geometric, we're going to find the common ratio, which we call R. So we've got to figure out what's what here. Okay, so first one. If it's arithmetic, is it arithmetic? I wonder. Well, if it's arithmetic, then when you subtract the second from minus the first, the third minus the second, the fourth minus the third, when you subtract them, you have a common difference. Let's see. Negative 2 minus 1 is equal to negative 3. Negative 5 minus a negative 2. Negative 5 plus 2 is negative 3. Negative 8 minus negative 5. See, I'm just subtracting this minus this. Negative 8 minus a negative is plus 5. That's negative 3. Well, look at all of these differences, or in other words, if you add or subtract 3, subtract 3, subtract 3, we keep either adding or subtracting the same numbers, then it is arithmetic. So the answer is yes, and the D value is equal to negative 3. The next one, number 4, is it arithmetic? I wonder, is 28 minus 7 the same thing as 112 minus 28? The same thing as 448 minus 112? I think we can find out that really quickly. 28 minus 7 is 21, and 112 minus 28, I don't think it's 21. No, it's 84. So that is a no. It's not arithmetic. So let's go on to the next. Is it geometric? If it's geometric, then when you divide two consecutive terms, you get the same ratio. Is 28 divided by 7 the same thing as 112 divided by 28? The same thing as 448 divided by 112? Remember, you're dividing instead of subtracting. Let's see, 28 over 7 is 4. 112 divided by 28 is 4. 448, I'm using my calculator off to the side here, divided by 112 is 4. So is it geometric? The answer is yes, it's geometric because the common ratio is equal to 4. When you divide them, you get the same number. Okay, oops. Next one. Let's see. Is negative 2 minus 5, we're going to see if it's arithmetic. Is negative 2 minus 5 the same thing as 4 minus negative 2? The same thing as negative 1 minus 4? The same thing as 3 minus negative 1? Let's start this out. Negative 2 minus 5 is negative 7. 4 minus negative 2 is equal to 4 plus 2, which is 6. So this is a no. It's not arithmetic. Let's see if it's geometric. G. Is negative 2 over 5 the same thing as 4 over negative 2? Well, negative 2 over 5 is negative 0.4. 4 over negative 2 is negative 2. Those two numbers are not equal, so this answer is no. It's not arithmetic, it's not geometric, this is a neither. And then the last example with fractions. Is it arithmetic? Is 3/4 minus a negative 3 the same thing as negative 3/16 minus 3/4? Let's see. I'm going to use my calculator here. That's okay. 3/4. Oops, get that 0 out of there. 3/4 minus a negative 3, which is plus 3. That's 3.75. Is that the same thing as, I'm going to use my fraction button here, is that the same thing as negative 3/16 minus 3/4? 15/16, and let's see, this 3.75 as a fraction is, no, they're not the same. It's 15/16. It's 0.9375. So the answer is no. It is not arithmetic. Let's see if it's geometric. If you divide 3/4 by negative 3, let's see, 3/4 divided by negative 3 is negative 0.25. Let's say negative 3/16 divided by 3/4. Divided by positive 3/4. Oops. Better put some parentheses in here. Oh, that's negative 0.25. Looks like it's going to be it. Negative 0.25. And the last one is 3/64 divided by negative 3/16. 3/64 divided by negative 3/16. Yep. So the answer is yes, it is geometric, and the R value is negative 0.25. Now we have to write a rule for the geometric sequence. Now a rule, remember, is AN equals A1 times R to the n minus 1 power. That's that formula you have to memorize, so that's going to be used in all of these problems. So what we need is we need A1 and we need R. So in this case, the first term is 4. The R value is 12 divided by 4, which is 3. So the rule is AN equals the fourth term times 3 to the n minus 1. Note the parentheses, and don't ever multiply 4 times 3. Don't do that, because 3 gets raised to the power and 4 doesn't. So then they want us to find A8. So to find the 8th term, it's equal to 4 times 3 to the 8 minus 1, 7. So 4 times 3 to the 7th is 8748. Or you can just keep multiplying times 3 times 3 times 3 times 3 times 3 and get out to the 8th term, but this way's faster. The nth term is the first term times R to the n minus 1. The nth term is the first term, which is 1, times R. Well, it looks like you're going to be multiplying times 6 to the n minus 1 times 6. Everything gets multiplied by 6, so that's the R value. So that's the rule. I guess we should box out what the rule is. There's the rule. And the 8th term is 1 times 6 to the 7th power. And 6 to the 7th power is 279,936. The 8th term. The next one, let's see what R is. R is the second term divided by the first term, negative 6 divided by 2, which is negative 3. So the first term is 2 times, look at the negative 3 in parentheses, that's really important, to the n minus 1 from our formula up above. And the 8th term is 2 times negative 3 to the 7th power. So 2 times negative 3 raised up to the 7th is equal to negative 4374. 4,374. The next one, well, let's see what our value is. Our value is 2/9 divided by 1/3. I'm going to do this without a calculator because I know when I divide two fractions, it's the same thing as flipping the second one. 2/9 times 3/1 because you can flip that second fraction. And if I want to multiply this, 3/9 turns into 1/3. So this is 2/3 times 1/1. The R value is 2/3. Or you could do it in your calculator too. Just make sure you put parentheses around these values. So the nth term is the first term, which is 1/3, times the R value, which is 2/3, times n minus 1. It's a little tricky with those fractions. The 8th term is 1/3, parentheses 2/3, to the 7th power. So let's see what that turns out to be. 1/3 times 2/3 raised up to the 7th power. And I thought I'd get a long decimal here, which I don't want to write down. I am going to do a math frac, see if it turns into a fraction. Oh, it does. Good. So 128 over 65/61. It's a lot easier to write that. 128 over 65/61. Oh, good, they tell us what R is. We don't have to figure it out ourselves. That's even easier. The nth term is the first term times R to the n minus 1. That should have been the first example. That was so easy. So the 8th term is equal to the first term times -1/3 to the 7th power. Let's see what that is. 3 times -1/3 to the 7th. Whoops. To the 7th power. Ew, I think I'll math frac that. -1 over 729. And then the last example, oh, this is just as easy. They tell us the first term, which is 8. They tell us the R value, which is 1/2, and we raise it to the n minus 1. So there's your nth term. And so the 8th term is equal to 8 times 1/2 raised up to the 7th power. Let's see what that is. 8 times 1/2 raised up to the 7th. I think I'll math frac that. 1 over 16. And that's all I'm going to talk about today. We just have a little bit left to finish up with this chapter. We're going to talk about something called a geometric series on the next video. So I'll wait till next time. Have a good night.